Yeah, I know. Someone outside was wishing they were in here. No. Okay. So we are solving an exponential equation on example 3C. It says solve, give a simplified exact answer, and then if you're interested, give a 3-decimal approximation. I'm going to leave that for you to do. Or maybe I won't leave it for you to do. I'll go ahead and do it. I just need to start loading my calculator. Okay, so if we look at this problem, we've got 3 to the first power times 5 to the 2x minus first power equals 4 to the first times 6 to the 1 plus x power. The first thing you should try to consider is on the factors that have the exponential variable, can you write 5 and 6 in terms of the same base? In other words, can you use the GTBTS? Not really, right? 5 is a prime number, and 6 is not one of its factors. So you can't write those in terms of the same base. Now, if one of them was 5 and the other was 25, or if the right one was 6 and the other one was 36, then it'd be possible. So we're not going to have to try and clear out the 3 and the 4. We're just going to embrace it as it is. And because we have different bases also, we're not going to take log base 5 of both sides, and we're not going to take log base 6 of both sides. We are going to take the log of both sides, but what base are we going to use? The natural base, right, which is ln. So that would be your next step. On here on the line below it, ln of 3 times 5 to the 2x minus first equals the natural log of 4 times 6 to the 1 plus x. By the way, this problem is very important, so maybe put an asterisk by it. The algebra involved is pretty important. Okay, sweet. So now what we do is we expand both sides. If you expand the left side, you have 2 factors, so you'll have 2 terms. And then the exponent 2x minus 1 will slide out front. So it becomes the natural log of 3 plus the quantity 2x minus 1 times the natural log of 5. So hopefully you can do that now in one step. And you don't have to animate bringing the exponent to the front. Equals, very similarly on the right-hand side, you'll have the natural log of 4 plus the quantity 1 plus x times the natural log of 6. Everyone good with that? Okay, now what is our objective? Our objective is to get the x terms together, right? But right now, both of those x's are trapped inside a factor, a binomial factor. So what we have to do is expand it out. So here we go. This is the natural log of 5, the number, the natural log of 5. We can distribute that number into both of those terms. That becomes 2x natural log of 5 minus the natural log of 5. Now, does anyone take an issue with us doing that? Armstrong, I thought you raised your hand, but you were just adjusting your sleeve. Okay. I have a hair trigger on questions. This is what is not allowed. Some people say, I thought you can't distribute a log inside something. And here's what's not allowed. If that were the natural log of 2x minus 1, in other words, the 2x minus 1 were the argument, this is what you cannot do. You cannot call that the natural log of 2x minus the natural log of 1. But we don't have that situation. We have the natural log of 5, which is a number, times a separate 2-term dude. So we can distribute it in there because 2x minus 1 is not the argument. So if you were thinking that, there you go. If you weren't thinking that, then thanks for tolerating me saying that. All right, similarly on the right-hand side, we got the natural log of 4, plus now we got to distribute the natural log of 6. So 1 times anything is itself, and then plus x natural log of 6. Now again, a word about that. Natural log of 6 is a number, and x is the variable, so that's like a linear term. I write it as x natural log of 6 because if you flipped it around and wrote it like that, the natural log of 6 times x, that sure looks a whole heck of a lot like what? That looks like the natural log of 6x, which it's not. That's not what we intended. So if you wanted to put the x separately in the right-hand side, you would have to set off one of them or both of them with parentheses. So it's just a little bit easier to write the x in the front. Okay, so now that we have it expanded out, we're kind of like in Algebra 1. We got to collect our x terms on one side, and everything that doesn't have an x gets collected on the other side. So I have 2 terms now that have x's in them, and I highlighted them. So now we'll collect those on the left-hand side. So the 2x ln of 5 stays there, and red rover, let x ln of 6 come over. He accepts the invitation, and now he's negative. Not bitter, but negative. And on the right-hand side, the two things that aren't highlighted, they'll stay put. The natural log of 4 plus the natural log of 6. And they are welcoming over their two new friends, positive natural log of 5 and negative natural log of 3. That's just rearranging terms. So good so far? All right, so now the magical step is to get a single representative x factor. And we've seen this before. Since those are unlike terms, we're going to factor out the x. And we're left with 2 natural log of 5 minus the natural log of 6. And then we're still left with everything over here on the right-hand side. The natural log of 4 plus the natural log of 6 plus the natural log of 5 minus the natural log of 3. Wonderful stuff happening over there. And now we're around the third, heading home. We're going to score. The ball's in the outfield. We're going to win the World Series. What do we do next? Divide by that. Good. We have x times the number. We'll divide both sides by the number. And again, you don't have to show that. You just go x equals. And now it's going to be everything on the right-hand side, which I'm going to cheat here. I'm going to copy that. Paste it. So there's your numerator, all divided by the denominator, 2 ln of 5 minus ln of 6. And this is one version of the exact answer. One version of the exact answer. Now, we could actually do a couple of things here to kind of play with our final answer like we play with the snow here. We can actually condense any number of those terms. Do you see any two terms up there? Bless you, bless you, bless you. That would be worth combining or condensing. Notice you only have one negative term, right? Natural log of 3. What if you combined it with that positive term, natural log of 6? Let's see what that would do. That would turn that into a natural log of what? 6 divided by 3. What's 6 divided by 3? 2. So there you go. That was kind of worth it. I took 2 logs and turned it into 1 log. And now, if you want, the 2 that are not highlighted, plus the natural log of 4 plus the natural log of 5, that can turn into the natural log of what? If you condense the 4 and the 5. 20, yeah. Now 20 is bigger than 4 and 5. That's not really the purpose of logs, but 20 is still a manageable number that I might actually do that on a test or something. Okay, so that's a possibility. In the bottom, the 2 in front of the ln of 5, it looks good there, but we could actually bring it back up and call it the natural log of what? 25. Good. And then minus the natural log of 6. I'd probably leave that. Now, if 6 were a factor of 25, like if that had been the natural log of 24 minus the natural log of 6, then it would be worth condensing those again to get it to a single integer. So with fewer terms, this is something that I would consider to be more simplified, even though the arguments are a little bit bigger. All right, so now here's how we can check. If you're doing these problems on your worksheet, which you're not turning in but still doing, right, for practice, and you want to know if that's right because it looks strange, it looks unfamiliar, you've never worked a problem like this before, go to the calculator and type it into your home screen. So alpha y equals, I'll type in the final version we came up with, natural log of 2. Make sure you close your parentheses because the calculator will automatically open them for you. So there's my new numerator, and the denominator is the natural log of 25 minus the natural log of 6. So I'm going to hit enter, and it's 2.584. So I can put underneath my answer squiggles 2.584. So what's a nice set for answers are a simplified exact answer accompanied by a 3-decimal approximation. Now, how are we going to know if that's the right answer or not? Good question. I'm going to store this right here. See all the decimals? I'm going to hit stow right above the on button, and I'm just going to store it as X. I can store it as any letter, but X is just a one-button letter instead of alpha anything. Now, that's stored it with all the decimals there. So now all we have to do to see if it's correct is plug it back into this original thing at the top. And when I plug it into the left and plug it into the right, I should get the same answer. Let's see what we get. We get 3 times 5 to the 2x minus 1 power. We get that number. And if I do it on the right-hand side, 4 times 6 raised to the 1 plus x power. If I hit enter and we did our work correctly, what should show up? Not Tyler Ullman, but 2463. Yeah. So there you go. We did it, Tyler. What do you need? I'm recording. Right, basketball game. Okay. Well, I'll be doing the same thing there that I'm doing now. I'll be recording. So we'll talk to you. You can watch the video. All right. That isn't a very important problem, right? I said that was a very important problem. We're in here for another 14 minutes. This is where I'd normally give you one like that to try on your own and see how you did, but I'm going to kind of skip that because we're short on time. So make sure that you go to your worksheet, find the one that looks like that, and try it. Practice, and see how you do. So I think we have time for maybe one more. So I'm going to jump to example 4c. This is another exponential equation, and we want to solve it. So ultimately, we need to have x equals. Now, if you look at the exponents, it's negative x and positive x. They're very, very, very similar to each other. How do you think we're going to go about solving for this one? Well, if I take the natural log of both sides as it sits, and you don't have to write this down because it's ultimately not going to work. What's the problem with me taking the natural log of both sides right away? First of all, does it free up the x's from the exponents on the left-hand side of the equation? It does not. It actually traps them. Because remember, we have two terms, and we're not allowed to distribute the log into its own argument. So that doesn't help us get x down on the ground floor. Plus, on the right side, what is the natural log of negative 2? Don't think too hard. D and E, right? You can only take logs of what types of numbers? Positives. So that doesn't help at all. So we have successfully found one method that doesn't work. So I'm going to shrink that down and put it over here on the side where all of my failures go. All right. So if I then brought the negative e to the x to the other side and called it positive e to the x minus 2, now can I take the natural log of both sides? Don't write this down. It's not going to work. Unless you want a record of something that fails. Now on the left, I can expand it because it's now a single factor. That's the natural log of 3 minus the natural log of e to the x. So that actually works. But does that free up all the x's? No. This one over here on the next line would be 3 natural log of 3 minus x. So that guy's free now. But I've trapped this guy over here. Criminy, I've trapped him. That doesn't work. I need to get all my x's together. So here's another successful failure. All right, so here's what you're going to do. I'm going to show you the end side. You got a negative exponent on the first one. Let's rewrite it without the negative exponent. That's 3e to the positive x. Everyone okay with that? Just bring that factor from the bottom and make it e to the positive x. Now you say, hooray, hooray, I have a fraction. To clear out a fraction from an equation, you're going to multiply both sides by the LCM of your denominators. We only have one denominator. It's e to the x. So what I'm going to do now is multiply the left side by e to the x and the right side also by e to the x. That works. Now what happens in the first term when you distribute? The e to the x's divide out, leaving you with 3. Now remember, in general, it's not good to get rid of variable information from any equation. But I'm not losing the e to the x that I just divided out entirely. He's actually going to show up in 2 other terms. So we're not just getting rid of it. This becomes then e to the x times e to the x, which is e to the what? What's e to the x times e to the x? It's e to the, should be 2x, right? When the bases are the same, you add the exponents. X plus x is 2x. And on the right-hand side, we get minus 2e to the positive x. And now you're like, yay, I got rid of my negative exponent. We're still in the same boat, though. If I try to take the natural log of both sides, I'm going to be liberating the guy on the right now, but trapping the guy on the left. So here's what you need to do. I'm going to collect everything on the right-hand side. So I get 0 equals. The negative e to the 2x becomes positive e to the 2x. Then I have the minus 2 e to the x, and then I have minus 3. Does this right here look like anything to anybody that's remotely familiar? Say it louder. It's a quadratic. Very good. It's a quadratic trinomial. Except instead of plain old x squared and plain old x, we have e to the 2x and e to the x. Bless you. This is analogous to what I wrote right below there. The only difference is, like I said, instead of x, we have an e to the x. Okay? So if we had x squared minus 2x minus 3, could you factor that? And the answer is, heck yeah, we could. So let's go ahead and factor it as if it were an x. That would be an x and an x, and factors of negative 3 that add up to negative 2, or negative 3 and positive 1. Well, guess what? It's going to work the exact same way for us, except instead of x, guess what it is? It's e to the x, yeah. So we are going to get it as e to the x minus 3 and e to the x plus 1. So now you know that quadratics don't have to just be an x squared and an x. They could be an x to the 4th and an x squared, as long as the larger exponent is 2 times the smaller exponent, which we have here, it's going to be a quadratic. Okay, it might just be in terms of something else instead of x. So now you can look for that. And anytime you have a problem like that, where you have like an e to the negative x and an e to the x, it will eventually turn out to be a quadratic, which you should be able to factor. Now keep it equal to 0. Once we have it factored and equal to 0, remember we can actually set each factor equal to 0 by the zero product property. So e to the x minus 3 equals 0, or e to the x plus 1 equals 0. All right, so now we're making progress. We took a problem that was too hairy on its own, and we've broken it down into 2 problems, which might seem like more work, but they're both manageable now. So now all you have to do is solve each of these, and you're going to do it by isolating the exponential factor. So the left equation becomes e to the x equals 3, and now how do I un-e this equation? Take the natural log of both sides. So I get natural log of e to the x, bless you, equals natural log of 3, bless you. And of course on the left, the natural log of e to the x is just x, and we're left with the natural log of 3. There's one of your solutions. Yay! Now on the other side, very similarly, we separated e to the x, oops, I wrote that backwards. E to the x equals negative 1, take the natural log of both sides, and you get x equals the natural log of negative 1. If you box it up and walk away, did you get them both? No. What do we know about the natural log of negative 1? It does not exist. Good. We can only take logs of positive numbers. So the only solution is the natural log of 3. There you go. So look for that in the worksheet. Go to the worksheet. There is one that has like a negative exponent and a positive exponent. And by the way, it could be like negative 2x and positive 2x. As long as they're the same exponent but opposite signs, you can always do the problem the same way. Write it as a fraction, clear out the fraction, gather your terms, and factor. Okay? So we do have time for one more. Good. Look at part D now. That looks a whole heck of a lot like what on the left? Say it. Logistic. Yeah, logistic function. Yeah, good. That was a good clue I gave you, right? Logistic function. When we had the logistic function last time and we set it equal to a desired value like 200, I told y'all we had to solve it graphically, right? Put this in y1, put this in y2, and that's how you're going to do it ultimately on your test question next Wednesday. But now that we have logs in our arsenal, we can actually solve this without using the calculator. We can get an exact answer. So we're going to peel back the layers so we can get down to that x equals something. All right, step 1, I'm going to multiply both sides by the denominator. So we get 500 equals 200 times 1 plus 25 e to the 0.3x. I multiplied both sides by the denominator. So it divided out on the left, and it became a factor on the right. All right, now instead of distributing the 200, which would work, because I have a number on the left, I'm going to divide both sides by the 200. And I'll actually show that here. Divide that by 200, divide that by 200. So we have 1 plus 25 e to the 0.3x on one side. I'll now put it on the left. And we have 500 200ths on the left, which simplifies to 5 halves. Okay, cool. So now we have the x in the numerator. Now it's just a matter of getting to the exponential factor. We'll subtract 1 first from both sides, and we're left with 25e to the 0.3x equals 5 halves minus 2 halves is 3 halves. Now we got to get rid of the 25. I'll do that by, instead of dividing by 25, I'll multiply both sides by 1/25, which is really the same thing as dividing. So now we get e to the 0.3x equals 3/50 if you multiply straight across. And now we're almost there. Now what do? We got to un-e it because we got the exponential factor isolated. Now we take the natural log of both sides. And you get on this side 0.3x equals the natural log of 3/50. And now there's one last step to go, right? What's another way to say 0.3? What's the correct way to read that? 3/10. So I'm going to actually write 0.3 as 3/10. Reason being is if you ever have a fraction in a problem and a decimal, that's mixed notation. That's like me teaching in English and Spanish, right? There are two different ways to denote parts of things, fractions and decimals, and you don't want a hybrid answer. So now to solve for x, I'll multiply both sides by what? To get rid of the 3/10. 10/3, the reciprocal. And I'll show that there. So our final answer is 10/3 times the natural log of 3/50. So maybe, boy, this would be good. Since you have your calculator on the test on next Wednesday, it would be great for me to allow you to solve this like we did before by finding the point of intersection between the graphs of y1 and y2, and then have you verify by solving it algebraically. And the number you get on your calculator where they intersect should equal this number here. So look for that. That would be a nice final little piece in the logistic equation. Solve by hand the value where this logistic function equals 200. All right? So we did it. We'll stop right there. Tomorrow we will not be here because it's Saturday. Golly, wow. But Monday we'll pick up with example 7, and then I'll tell you briefly what your multiple choice test will look like next Tuesday, okay? So be working on this worksheet, practice, but it's not going to be something you'll ever turn in. All right, thanks again for coming today.